Hello everyone. In this video, I will explain equation of plane passing through 3 points. There are three major types of finding equation of plane: passing through 3 points, passing through 2 points and parallel to a vector, passing through 1 point and parallel to two vectors. There are abundant questions asked in JEE Main and JEE Advanced based on these three concepts. I will explain each concept with suitable examples picked from JEE Main or JEE Advanced. I may not cover all these three concepts in one video. It is very difficult. I'll teach very slowly because it is bit not difficult. It takes time to understand. Right. Well, so first I will explain what is meant by vector form of a plane. See, before that, you must know that if three vectors are A bar, B bar, C bar are coplanar, if three vectors A bar, B bar, C bar are coplanar, then their box is equal to 0. Box of A bar, B bar, C bar equal to 0. So box is nothing but determinant. Well, okay. So here you see that the vector form of equation of plane passing through 3 points having position vectors A bar, B bar, C bar. Well, okay. Then the vector equation of plane is that R bar is equal to 1 minus T minus S into A bar vector plus TB bar vector plus SC bar vector, where T comma S are some scalars. This is the vector equation of plane passing through 3 points having position vectors A bar, B bar, and C bar. Well, so here you see, I have taken 4 points on the plane, 3 given fixed points, and 1 is the variable point. Right. Let us join with each of the points starting from A. Well, so joining with B and joining with P. Well, joining with P and one more joining with C. All right. So if you observe that, you see that AB bar and AC bar and AP bar are coplanar vectors. Well, so here I'm going to write that AP bar vector, AB bar vector, AC bar vector are coplanar. If R bar is any vector in the plane of B bar and C bar, then it can be written as a linear combination of A bar and B bar. That is, R bar is equal to XA bar plus YB bar for some scalars X and Y. Well, so you can write that AP bar equal to some T into AB bar vector plus some S into AC bar vector. Isn't it? Here we always take that this P as an R bar vector. That is a variable xi plus yj plus zk. So now we write that AP bar is nothing but OP bar minus OA bar vector equal to T into OB bar minus OA bar vector plus S into OC bar vector minus OA bar vector. It is so simple. It is just application of coplanar vectors or coplanar points. So now here given that this is the OA bar vector, this is nothing but OA bar vector. and B bar vector is nothing but OB bar vector, and C bar is nothing but OC bar vector. Well, substituting those position vectors here, OP bar is nothing but R bar minus A bar equal to T into B bar minus A bar plus S into C bar minus A bar. You just simplify it, you will get that R bar is equal to sending A bar that side and taking A bar common. A bar into, you will get that 1 minus T minus S plus TB bar plus SC bar. All right. So this is the equation of plane. Well, further, here you see that A, B, C, D are all coplanar vectors. They are all coplanar vectors, right? So A, B, C, P are coplanar, implies XA bar plus YB bar plus ZC bar plus WR bar equal to 0 bar. Implies. You just compare the components of A bar, B bar and R bar. X is nothing but 1 minus T minus S. Y is nothing but T. Z is nothing but S. W is nothing but minus 1 after bringing that LHS R bar into RHS. So that you will get X plus Y plus Z plus W equal to 0. Well, so this is the one format of equation of plane that is expressed in vectors. Now, I will write the same expression in the box form. Here you see that AP bar, AB bar, AC bar are coplanar. So therefore, their box is 0. Their box is equal to 0. Right? So box of R bar minus A bar, here I'll write that, or box of AP bar vector, AB bar vector, and AC bar vector equal to 0. Even though plane is not included in JEE Main in 2024 and also not included in 2025, but they may include from next year onwards. They may, but it is the part of the syllabus of JEE Advanced. So here AP bar, AB bar, AC bar are coplanar, therefore their box is equal to 0. And you can write that this LHS is equal to, that I can write that R bar minus A bar dot B bar minus A bar cross C bar minus A bar. C bar minus A bar equal to 0. Okay, this is equal to 0. This implies you can apply that cross product and later on dot product. Here you see that B cross C. This is B cross C. Next, minus B cross A. That you change the order, then it will become A bar cross B bar. And next, A cross C. Change the order, you will get C cross A equal to 0. And the rest is A cross A is nothing but 0 bar vector. Now taking dot product with R bar dot B cross C plus R bar dot A cross B plus R bar dot C cross A. Now start with A bar. minus A bar dot B cross C. You will get only one term with dot A bar and rest all becomes 0 because A cross B is perpendicular to A bar, A cross C is perpendicular to A bar. So now we got this result. We got this result. This R bar dot B cross is nothing but box RBC. This is box RAB. And this is box RCA. And this is box ABC. We got it. We have proved this result. Then you may have doubt that how can we use this concept in coordinate system? When they give 3 points, how to find out equation of plane containing all those 3 points? Well, so you with the help of this vectors, we can have that equation of plane passing through 3 non-collinear points. Well, so here you see that equation of plane passing through 3 non-collinear points, okay, x1, y1, z1, x2, y2, z2, and x3, y3, z3 is determinant of x minus x1, y minus y1, z minus z1. I'll explain. You see that this is the point A, this is the point B, this is the point C. Assume this is A bar vector and B is a B bar vector and this is a C is a C bar vector, and you take that R bar is equal to xi plus yj plus zk. Right. Nothing but any point on the plane is x comma y comma z. Isn't it? Well, so here this is nothing but R bar minus A bar vector. And the second one is nothing but B bar minus A bar. And the third one is nothing but C bar minus A bar. As we just had the proof that box of R bar minus A bar, B bar minus A bar, C bar minus A bar equal to 0. So I have used this concept to obtain equation of plane passing through 3 non-collinear points. It is just application of vectors, and then we use determinant rigorously. Every time we use that determinant format. Right. So passing through 3 points, nothing but first one is variable x minus x1, y minus y1, z minus z1. And then in that you substitute in place of x, x2, in place of y, y2, in place of z, z2. And again, x3 minus x1, y3 minus y1, z3 minus z1. Now we'll have a few questions of JEE main. Okay, here is a question. All right. So it is a two-tier question. So what is meant by two-tier question? They match two concepts. That is a two-tier question. Let P be the plane passing through 3 points. See, P be the plane passing through 3 points, right? Assume this is x1, y1, z1, x2, y2, z2. Okay, every time I won't write for the next questions. This is the first question, so I'm explaining with complete details. All right. So this is not alpha. This is an A. Okay, small. This is a printing mistake, and this is A. Well, let P be the plane passing through how many points? 3 points, where alpha is a natural number. If the distances of the points A and B from the plane are 2 and 3 respectively, then the positive value of A is dash. This is the question. So it is not one tier question. It's not enough to find equation of plane. After that, you have to find perpendicular distances. Well, so first we will find out the equation of plane. Well, so what is the plane equation? Just now we have seen that formula. Determinant of x minus x1. So x minus 5, y minus y1, y minus 3, z minus 0. Next, b minus a. 13 minus 5, 8, 3 minus 3, 0, and minus 2. Next, x3 minus x1. That is minus 4, 6 minus 3, 3, and 2 minus 0, 2. Then you will get equation of plane. Now you expand the determinant. This is 0, 6 into x minus 5. I'll write little speed. This is 16 minus 8. So minus 8 into y minus 3. All right, next 24 into z. 4 into z equal to 0. All right, you can cancel by 2. So you will get 3x minus 15 minus 4y plus 12 plus 6z, 12z equal to 0 after cancelling by 2. So we got that 3x minus 4y plus 12z minus 3. We got this plane. We just need to verify whether we got correct plane or not. For that, you just substitute any one of the 3 points. Let us substitute the first point on the plane, right? 3 into 5, 15, minus 12, 0, minus 3. Yes, it is satisfied. Now plane is correct. Well, now here you see that the distances of A and B from the plane are given 2 and 3. So I'll write the perpendicular distances. The perpendicular distance from x1, y1, z1, from the point x1, y1, z1 to the plane ax plus by plus ez plus d equal 0 is like a straight line in 2D. Modulus of ax1 plus by1 plus ez1 plus d by under root a square plus b square plus c square. Okay. So I'll write that perpendicular distance from the point A to the plane. So 3 into 3 minus 4 into 4. I'm just substituting the point A in the plane plus 12 alpha minus 3 by root over a square plus b square plus c square. This is nothing but under root 169. So that is 13. That's given 2. So we got that 12 alpha, right? This is minus 16, minus 3, minus 19. This is plus 9. So minus 10 is equal to right side I can write plus or minus 26. So either alpha equal to 3 or something else you will get. But here you see it is given that alpha is a natural number. Alpha is a natural number. Other one you will get that alpha is equal to minus 16 by 12. Anyway, we do not consider it. So we got that alpha is equal to 3. Now the perpendicular distance from the point B, So modulus of, right, 3 into 2, substitute point B, minus 4 into alpha, plus 12A, minus 3, whole by 13 is equal to given as a 3. That's it. We'll get the answer straight away. Okay. Here you see that alpha is equal to 3. You substitute here. You substitute alpha is equal to 3. This is 6 minus 12 minus 15, 9 plus 12a is equal to plus or minus 39. All right. Okay. Once again, I'll check that minus 12, minus 3, minus 15, minus 15 plus 6. So this is minus 9. So we got A, we want that positive value of A. So therefore, A equal to 39 plus 9, 48 by 12. That's equal to A is equal to 4. I leave the other value of A. This is the two-tier question. We have to find the equation of plane passing through 3 points, and then we have to find the perpendicular distances. We'll see another question. Now, see, this is also two-tier question. It's not merely they are asking, find the equation of plane passing through 3 points, and they will add something like finding foot of perpendicular from a point or image, or which of the following points does not lie on the plane, does not lie on the plane. Instead of lying on the plane, sometimes they ask, does not lying on the plane. Here you see that image of this point in the plane passing through 3 points A, B, C is Q alpha beta gamma. Then what is alpha square plus beta square plus gamma square? Question is very straightforward question. So we just need to find out equation of plane passing through A, B, C. So what is the ABC plane? Right, ABC plane we want. What is this ABC plane? Again, determinant of, remember, x minus x1. So x minus 1, I'm just taking the first point as x1, y1, z1. And y minus 2, z minus 0. Now b minus a coordinates are 0, 2, 1. Next c minus a, minus 1, 3, and 1 equal to 0. So we will get the plane equation. Well, this is 2 minus 3, that is minus 1 into x minus 1. And this is 0 minus of minus plus 1 it becomes. So minus of y minus 2. And this is 2z plus 2z equal to 0. We will get the plane very fast, passing to 3 points. So you will have minus x minus y plus 2z. And this is plus 3. You just need to multiply by negative sign so that x coefficient is positive. In fact, it is not necessary. But anyway, we do it. So we got the plane. We got the plane. We have to verify whether this plane is correct or not. Because sometimes we may commit mistakes in expansion of determinant. Substitute the point A. X is 1, y is 2, plus 3, z is 0, minus 3 equal to 0. Plane is correct. Now we need to find out foot of perpendicular. Right? So you try to remember that foot of perpendicular from a point on a plane. Sorry, this is image. Well, so image formula is like in straight lines, two-dimensional geometry. Here alpha minus 1 by here x coefficient is 1. Beta minus y coordinate of P by here y coefficient is 1. Z, sorry, not Z, gamma minus 6 by Z coefficient here minus 2 equal to minus 2 times of minus 2 times of. Substitute these P coordinates in the plane, that we'll get that 1 plus 2 minus 12 minus 3 by a square plus b square plus c square is nothing but 6. All right. Okay. So this is 12 by 6, that is 2, and you will get 4. It is minus 12. This together, it is a minus 12. You will get 4. Now equate 1 by 1. Okay. So if anybody do not understand that how to find a foot of perpendicular, please watch foot of perpendicular in my channel. How to find a foot of perpendicular and image of a point on the plane or in a plane. So now equate the first one and the last one. You will get that alpha is equal to, just do the cross multiplication, alpha equal to, you will get 5. Okay, equate these two. You will get beta is equal to 6. And at last, equate these two. Gamma is equal to minus 8 plus 6, that is minus 2. We got it. Right? So therefore, what is alpha square plus beta square plus gamma square? That's equal to 25 plus 36 plus 4 is equal to 65. It is also two-tied question. We'll do one more question. Here is something a very interesting and a different type of question. Let a unit vector OP cap make angles alpha, beta, gamma with positive direction of coordinate axis OX, OY, OZ respectively, which means that indirectly they have given directional cosines of OP vector. Okay, those are cos alpha, cos beta, cos gamma. They have given that beta belongs to 0 to pi by 2. Cos beta is positive. OP is perpendicular to the plane passing through these 3 points. OP is perpendicular to a plane passing through these points. Then which of the following is true? So OP is perpendicular to the plane passing through these points is nothing but OP cap is the direction, is a normal to the plane. It is the unit normal to the plane. OP cap is unit normal to the plane. Anyway, first we just need to find out what is the plane equation. So again, we use the same technique to find the equation of plane. So x minus 1, I'm just taking the first coordinates as x1, y1, z1. First point. Y minus 2, z minus 3, 2 minus 1, 1, 3 minus 2, 1, 4 minus 3, 1. Right? C minus A, 0, 3, and 4 equal to 0. Right. Well, this implies x minus 1 into this 4 minus 3, 1. Minus of y minus 2 into 4 minus 0 plus z minus 3 into this 3 equal to 0. We got the plane. So we got the plane x minus y minus 4y plus 3z, isn't it? And minus 1 minus 9 minus 10, okay, plus 8 minus 2 equal to 0. All right. So what are the DRS of normal? DRS of normal to this plane. Normal to the plane. 1 x coefficient, minus 4 y coefficient, 3 z coefficient. These are the DRS. Well, what are the DCs of the normal to the plane? You just need to divide by its magnitude. 1 by, you can say this is 16 plus 9 plus 1. Root over 26 minus 4 by root over 26. 3 by root over 26. Either this set you have to take or another set is, or multiply by negative sign, minus 1 by root over 26, 4 by root 26, and minus 3 by root 26. Well, here you see that OP cap is perpendicular to the plane. OP cap is perpendicular to the plane. So OP cap is normal to the plane. OP cap is unit normal to the plane. Unit normal. Normal to the plane. To the plane. It makes uh, angles alpha, beta, gamma with positive x, y, z. But here you see that they have given that beta belongs to open 0 to pi by 2. So therefore cos beta is positive. Cos beta is positive. So we have to choose that this is cos beta. This is eliminated. Then this is cos alpha. And this is cos gamma. Got it? Well, okay, here OP cap, this is separate, OP cap is like this. So here cos alpha, it is negative and cos gamma is also negative. So therefore alpha belongs to second quadrant, gamma also belongs to second quadrant. Both alpha and gamma belongs to second quadrant. So therefore option B is true. They belongs to second quadrant. Such a nice question they have framed. One more question here. A plane passing through the 3 points and O is the origin, P is a point, then the projection of OP on this plane is of length dash. This is another kind of question. Well, we'll have the plane P. Okay, plane P, that O is the origin and P is this. Okay, don't be confused with the name. I'll write that this is plane. Plane. Okay, determinant of x minus 1, y minus 2. I am taking the first point as x1, y1, z1. Z minus 3. All are similar questions. Well, b minus a is nothing but 1, 1 minus 2. C minus a is nothing but 1, 2 minus 1 equal to 0. So we'll get the equation of plane just by expanding this determinant x minus 1 into minus 1 plus 4, that is 3, minus y minus 2 into minus 1 plus 2, that is into 1, plus z minus 3 into 2 minus 1, 1 equal to 0. So we got the plane equation that 3x minus y plus z. What is the constant? This is minus 3 and plus 2, that is minus 1, and plus 3, nothing but minus 2 equal to 0. We'll verify whether this is true or not. We just substitute C coordinates, this time C coordinates. So 6 minus 4, 2, right? 6 minus 4 minus 2 plus 2, 0. Once again, this is 6, okay, plus 2, something gone wrong. I'll verify it once. I got it. This is minus 3, this is minus 3, minus 6, and this is plus 2. So this is the way we have to verify it. So this is a minus 4. Now the plane is we got. Now we need to find out what is the projection of OP on the plane. Well, So we need to find out the projection of OP. Assume this is O and this is the point P, given that 2 minus 1, 1. We need to find out the projection of OP on the plane pi. Assume the foot of perpendicular from origin on the plane is L, from P is M. So LM is the projection of OP. LM is the projection of OP. Now you just need to draw a line from O and parallel to LM. Assume this is Q. Assume this is Q, right? So the projection of OP on pi, on plane pi, is nothing but LM. That is nothing but OQ. Both are equal. Assume this angle is theta. Assume this angle is theta. Now it is nothing but normal to the plane. Normal to the plane, right? What is the normal vector to the plane? 3i minus j plus k. Normal to the plane, right? So here MP bar vector is parallel to, MP bar vector is parallel to 3i minus j plus k. This is normal to the plane. And what is OP bar vector? OP bar vector is equal to 2i minus j plus k. And assume angle between them is theta. So what is cos theta? What is cos theta? So here I am writing that cos theta is equal to MP bar dot OP bar vector whole by, okay, I'll take acute angle. There is no issue at all. Modulus of MP bar, modulus of OP bar. This is equal to, what is the dot product of these two? 6 plus 1 plus 1, 8. By magnitude of MP bar is nothing but root 11. And next one is root 6. We got it. So this is nothing but 8 by root over 66. And what is the magnitude of OP bar vector? That is equal to root over 11. Sorry, root 6. Now we need to find out OQ. We need to find out OQ. See, LM is nothing but OQ. So apply what is sine theta from the triangle. From triangle OQP. What is sine theta? Sine theta is equal to, right, opposite side OQ by OP. Implies OQ is equal to, which is the projection of OP on the plane. That's equal to OP is nothing but root 6 and sine theta. So sine theta is nothing but root over 1 minus cos square theta. Root over 1 minus cos square theta. So you will get that this is 66 minus 64, that is 2 by 66. Got it? Right. So that this is equal to root over 2 by 11. Option C is correct. So keep watching my channel and enrich your knowledge. In the next video, I'll explain the second part of equation of plane, that is passing through 2 points and parallel to a vector.